Hello, this is Mr. Gilmore with the 11.3 Part 1, the side angle side and angle side angle triangle area. So we've only begun the conversation on how to find the area of a triangle. We've seen there is the area formula of 1/2 base times height. However, in these next two lessons, as you can see, there's a Part 1 to 11.3, and then there's a follow-up 11.3 Part 2. We're going to find that there are other ways of finding the area of a given triangle based on its given information. We're not always going to have the base and the height. So what if it then fits into one of our triangle patterns, such as today, the side angle side and angle side angle? So again, I've already made mention of this. We've only just begin started with finding the area of a triangle. If we are given the information of a triangle, such as the base and its height, we can use the area of the triangle's 1/2 base times height. But as I said, it's not going to be the only way we can find the area of a given triangle. There are three more. We're actually going to investigate two of those today. We're going to see that there's the side angle side pattern. There's the angle side angle pattern, which also includes the angle angle side pattern. They're both the same because with both of those cases, we can find the area. We can find the missing angle measure of the third angle in each case, and then set it up as if we would find it in an angle side angle case. And then the last one we're going to see, which is in our next lesson, is going to be the side 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 case. And we also have already covered our special case. The 1/2 base times height is really the HL, the hypotenuse leg case. So you notice we've gone through all 5 of the congruence principles: side angle side, angle side angle, angle side angle side angle, angle angle side, the side 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 case, and then the HL. So all 5 of those cases, we can actually find the area formula for each one of those 5 cases. We're going to start with a side angle side example, all right, and actually just look at how are we going to derive the area formula for the side angle side. Well, again, we can't just use 1/2 base times height. We have actually two sides of this triangle, the 3.6 and the 5, but that's really not enough to get the height of this. So how are we going to get the height? Well, of course, we can add one. We can actually create an altitude within our triangle, and we know that by this altitude, if we can find out what that length of the altitude is, we can then use the base, which is 5, the length of that altitude, which we're going to find to be h, and then we'll actually find out what the area of our triangle is by using the 1/2 base times height. So let's actually, with this same exact triangle that we just saw on the previous slide, let's actually find the area of this triangle. So what we need to do is actually calculate what is the area of this triangle by finding the height of this triangle. And to do that, we have a tool in with our right triangles that we actually help us, because remember that altitude actually creates a right triangle for us. We find ourselves working with this triangle with an acute angle of 33.7 degrees. What that means to us is we can use SOHCAHTOA. So if we take a look, our angle is 33.7. We're looking for the opposite side h, and we have the hypotenuse side 3.6. So we're going to use the sine. The sine of our angle is equal to the opposite over our hypotenuse. So the sine of our angle, 33.7, is equal to the opposite lowercase h over our hypotenuse, which is 3.6. Let's go ahead and solve for h. As we remember, the sine of an angle just turns into a ratio, so I'm going to go ahead and do that first. Sine of 33.7 turns into 0.5548. We're looking for the height, and we have that 3.6, which means let's multiply both sides by 3.6. We get the height is 3.6 times 0.5548, which then roughly comes out to be 1.9973. And so there we have it. There is our missing height. Now what we think about is we have that 5, which is our base. We can then use this to find the area of the triangle. So the area of the triangle is 1/2 base times the height, which is 1/2 5 times that 1.9973. And we roughly get, I'm going to round this to the nearest whole, or nearest decimal point here. And let me go ahead and do this real quick. Sorry, I thought I've already done this. Okay, so 1/2 times 5 times the 1.9973. We roughly get about 4.99. I'll go to the nearest hundredth. So there is the area of our triangle, 4.99. And we did that by actually using our trigonometry. So really, what did we do to actually calculate the side angle side? Let's actually put this into a general form, and that way we come across a kind of deriving another general form for finding the area of a given triangle. So it's the same triangle, but now we've actually taken out those three, the two sides, the three pieces of information, the two sides and the angle, and we replaced them with generic information. So we had side B, side C, and this angle alpha. Now, what we started with by doing was dropping in that altitude h, right? We called this altitude a length of h. And what we then did was we used our definition of sine with that angle alpha to actually solve for that missing side h was, which involved our side h and our hypotenuse at the length of c. So if I go ahead and solve for that that height, I got in this case the height is equal to, so multiply both sides by c. The height is then equal to c times the sine of alpha. Now, so there's our height. Now, our base, which again, actually conveniently is the side B, so the base is length of B, we come out then to find the area of our triangle is 1/2 the area of the base times the height, or the length of the base times the height. Well, in our case, the length of the base is the length of B, and the height is this value of C times the sine of angle alpha. And so this is actually another form that we can actually derive by using the side angle side pattern. So what we actually unpack here is this, that the area of a triangle is really 1/2 the product of the two sides times the sine of their included angle. So let's put this together into a conditional. So again, what just happened there? The area of a triangle is half the product of a pair of sides times the sine of their included angle. So as long as we have that side angle side pattern, we can actually then find the area of that triangle by using, again, this formula. Let me go ahead and write this formula again down. So area of the triangle is 1/2 the product of the two sides. Let's call the side 1, side 2, times the sine of their included angle. We'll just call that included angle alpha. So that would then be the area formula of our side angle side case, which you will find as one of the area formulas on your Pasha theorem handout. So be sure to take a look at that area, those examples on the area formula. So let's actually just put this into practice then. Let's find the area of a side angle side triangle again here. So the area is then, the area of triangle is 1/2 the product of the two sides. We'll call that side 1 times side 2 times the sine of their included angle. Well, again, we have a side angle side pattern here. So let's just plug in what we know. We have 1/2 8 times 6 times the sine of their included angle, which is 101 degrees. We pop that into a calculator. I'm going to round this to the nearest hundredth again, and we roughly get the area to be 23.56. And there we have it, the area of that triangle with the given two sides, their included angle, so we use the side angle side pattern area formula. Now we move on to the angle side angle case. Now the angle side angle case is a bit tricky. So here's what we're actually going to end up doing. We're actually going to use so in this case, we're going to use the law of sines, because with the law of sines, we're dealing with an angle side angle pattern. And with the law of sines, we can actually figure out a missing side. So we actually can figure out what the missing side C is, or the missing side A is. And either one of those, when we find that out, it's going to give us the side angle side pattern. So essentially what we're doing with the angle side angle is we're going to take the angle side angle and we're going to turn it into a side angle side. And the reason why we're doing that is because we already have a formula for the side angle side pattern. And so to figure out then the area of an angle side angle triangle, we're going to then turn it into a side angle side and then use that formula for the side angle side equation. So let's take a look then at using the law of sine, or let's remind you again what the law of sines is, and then we'll use the law of sines to actually find out either missing side A or missing side C, and then that turns it into a side angle side pattern. So remember what the law of sines is. Law of sines looks like this: the sine of an angle ratio to its opposite side, all of those ratios are actually equal. They're proportional to each other. So the sine of angle A over A equals the sine of angle B over B, which is sine of angle C over C. And we're going to use that then to find out a missing side measure and turn an angle side angle case into the side angle side case. So here's our example that we saw earlier. We're actually now going to find the area of this given triangle, and notice that it's in the angle side angle pattern. I'm actually going to find the missing side A, right? This is what I'm going to figure out. And when I find the missing side A, look what happens. When I find that missing side, I have another side of my triangle, which then turns my angle side angle case into a side angle side case. And then with the side angle side case, think about what we just did with that. With the side angle side, we were able to find the area of our triangle, which would be 1/2 the product of the two sides times the sine of their included angle. And so we're going to use this guy then after we find out our missing side A, we'll find out the area of a triangle. To do that, we've got to know what the side A is, which means we've got to then use the law of sines. To begin the law of sines, we always then find the missing third angle of our triangle. Since we have angle A and angle C, let's find missing angle B. By using our tasty formula, we come across then the angle measure for angle B is 108.4 degrees, which means now we have enough information to find the side of the length side A, because we need to know the angle opposite of it. So we have those pair, and we have then another pair of an angle and an opposite side. So let's go ahead and write out the law of sines then for this one. We have the sine of angle A, which the sine of angle, so I'll have to use the sine of angle A over A equals the sine of angle B over B. So we'll go ahead and fill in what we know. We know the sine of angle A is, 31 degrees, over side A equals the sine of angle B, which angle B is 108.4 over side B, which is 4.1. And then to save some time, I'm going to go ahead and cross multiply and solve. We get A roughly to be about 2.2. So I'll let A be 2.2. So what that means now is, now that we have this missing side, we have a side, angle, side pattern. Look at that. A side, an angle, and a side. And because of that, we can pop that into our area formula for the side, angle, side pattern. So area of the triangle, is equal to 1/2 the product of the two sides, 4.1 and 2.2, times then the sine of their included angle. And that I can actually type that all into my calculator all at one time. And I roughly get, I'll use an approximation here, I roughly get an area of, and I'll go to the nearest hundredth place, 2.93. So there is the area of our triangle using our side angles, our law of sines, paired with the angle side angle case to turn that into a side angle side case. So our last case, which is the side, we're actually going to save for the next part of this. The side case actually has another way of, there's actually two ways of tackling it. We could use the law of cosines to help us, or we can use a formula we're going to see in that lesson called the Heron's formula. And Heron's formula is really going to be our formula that really saves the day for the side case. So we're coming to the end of our 11.3 part 1 lesson. If you do have any questions on homework assignment, please do not hesitate to email me about that. What you're going to see on that is really the derivation of our side angle side formula, and then just diving right into finding the area of triangles that you're given the side angle side case, and then even the trickier cases, which is that angle side angle or angle side case. And again, if you do have questions on those, don't hesitate to email me. With that, be good and do good.